Hey everyone, welcome back to our Kubernetes deep dive. Today, we are going to explore what happens behind the scenes when you create a pod in Kubernetes. Whether you are deploying a simple Nginx application or complex microservices, understanding this workflow is key to mastering Kubernetes. Let's break it down step by step. Imagine you have crafted a YAML file to deploy an Nginx application and you are ready to create the pod. When you run kubectl apply command, the request is sent to the API server. The API server is the gateway to, to your cluster, handling all requests and ensuring they adhere to the rules and security policies you have set. The API server receives your request and first validates it, checking that the YAML file is properly formatted and the requested resource exists. Once validated, the API server writes the pod desired state to etcd cluster. So whatever written in pod definition file gets updated to etcd cluster, that these are the desired requirement or desired state of the pod. And etcd cluster ensures that the desired state of the pod is recorded and available for other component to reference. Now the Kubernetes scheduler comes into the picture. The scheduler examines the pod's resource request like CPU, memory, and any specific constraint. It then scans all available nodes in the cluster, looking for the best fit based on this criteria. So here you can see there are three worker nodes and scheduler is scanning all three nodes, checking for if the node has 2 GB memory available to run the pod. Once the scheduler identifies a suitable node, it assigns the pod to that node and updates the pod's definition in etcd cluster. With the node selected, the kubelet on the node takes over. So here you can see the scheduler gets response from this node that yes, it has 2 GB memory available. Then the kubelet on this node start communicating with the Docker container, start communicating with Docker runtime engine, and kubelet is it's an agent which is running on all worker nodes. So it communicates with Docker and asks Docker to pull all necessary images mentioned in the pod definition file, and then kubelet starts the containers, effectively bringing your pod to life on the node. The kubelet doesn't start the pod and walk away. It continually monitors the health of the pod, ensuring it's running as expected or not. It sends regular updates back to the API server, which track the actual state of the pod against its desired state. Finally, the controller manager plays its part in maintaining desired state of the cluster. If anything goes wrong, like if the pod crashes or node fails, the control manager, informed by API server, will take corrective action. This might involve restarting the pod, rescheduling it to different node, or performing other tasks to ensure that the desired state of your application is preserved. That's it for this video. Thanks for watching. I hope this deep dive into the pod creation process in Kubernetes has been insightful. If you have any questions or would like to see more in-depth topics covered, feel free to let me know. Don't forget to like, subscribe, and hit the bell icon for more Kubernetes content. See you next time.